So let's summarize what we learned on the previous page. First, a reminder about vocabulary. In slope-intercept form, we have y by itself on one side of an equation. M is the coefficient, that is the number in front of the x, and m tells us the slope of the line, that is the rise over the run. B is the y-intercept. That tells us where the line crosses the y-axis. Standard form is another way of writing the equation of a line. And in this case, what really matters the most is that x and y are on one side of the equal sign. So we have ax plus by equals c. In this case, a is not the slope, b is not the y-intercept, c is not anything in particular. When we have an equation written in standard form, a, b, and c are going to just be plain old constants. So an example of what an equation written in standard form might look like is this. We might have 2x plus 4y equals 3. In this case, we replaced a with the number 2, b with the number 4, c with the number 3. Standard form really just means x and y are on the same side of the equal sign. Okay, we've learned 3 different ways to graph. One is by plotting points. Plug in a value for x and find out what y has to be, or plug in a value for y and find out what x has to be. The second was the slope-intercept method. This is where we put a point at the y-intercept and then use the rise and run in the slope to walk ourselves to a second point on the line. The last was using the x and y intercepts. And we found that this method worked well here. All right, so when do we use slope-intercept form? When we have or can easily get y equals the rest of the equation. When we have the y by itself on one side of the equation, or when it's really easy to get y by itself on one side of the equation. So for example, if I asked you to graph the line y equals 2x plus 3. In this case, you already have y all by itself on one side of the equation. You already have the equation in slope-intercept form. So in this case, you could start by simply plotting the y-intercept, which in this case is at the point 0, 3. That's the y-intercept. And you can use your slope, 2. It's helpful to write this in its fraction form, which is 2 over 1. So we go up 2, rise 2, over 1, run 1. Up 2, over 1, and ta-da! There's the line. It's also useful to use slope-intercept form if it would hardly take any work at all to get an equation into slope-intercept form. For example, suppose you had an equation that looked like this. Y minus 3 equals 2x. Well, you notice the y is already by itself. All I would have to do to get this into slope-intercept form would be to add 3 to both sides. It's a real simple single step. And now I have the same equation here, and I can use the same process to graph it. When do we use the intercept method? When an equation is in standard form. So when we have x and y on the same side of the equal sign. For example, if I have the equation 2x plus 4y equals 8. X and y are already on the same side of the equation. So I know that when I plug in a 0 for x, this term is going to drop out. 2 times 0 plus 4y equals 8. Well, 2 times 0 is 0. And 0 plus 4y is just 4y. I did write all of this stuff out so that you can see how that 2x term drops away. But if you're good at mental math, you can recognize when I plug a 0 in for x, that term is going to go away. And what's left behind is 4y equals 8. That's an equation I can do in my head. I can divide both sides of that by 4, and I get y equals 8 over 4, which is 2. I can do the same thing when I plug in a 0 for y. 4 times y is 0. 2x plus 0 is just 2x. So I'm left with this equation, 2x equals 8. Again, that's an equation I can do in my head. Divide both sides by 2, and I get x equals 8 divided by 2, or 4. Again, I showed you the work here, but really this is a problem I could have done almost entirely in my head. And then I would simply need to plot these two intercepts, 0, 2, and 4, 0. And then I draw the line through them, and ta-da, my equation is graphed.